Let's discuss the linked data question from test 3, and the topic is heat transfer. So we have the linked data question 54 and 55. Okay, so two fluids A and B exchange heat in a counter current heat exchanger. So you have a counter flow heat exchanger. Say for example, the hot fluid is entering in this way, then the cold basically enters from outside in the reverse way because it's counter flow heat exchanger. Okay, so let's say this is THI in the sense the hot fluid inlet temperature, and this is hot fluid outlet temperature. The cold fluid enters this way, so it is TCI, and this is outlet TCO. So if you look at the temperature plot, the hot fluid temperature will decrease because it gives away some heat to the cold fluid. So, and the temperature decreases to THO. Now the cold fluid starts, this is along the length I'm plotting, length of the heat exchanger. Okay, and now the cold fluid temperature will increase from TCI to TCO. Okay, so what is asked? Okay, the effectiveness of the heat exchanger is given 75. Okay, so another thing is they have not given whether this is a parallel flow or so we have just assumed it is a parallel flow. I mean, this is what happens in a counter parallel flow. Okay, so now effectiveness is given, the fluid enters, so the THI, the inlet temperature of the hot fluid is given. Okay, and the fluid B is cold, which is 20 degrees centigrade is given, and the mass flow rates of the fluid A is 1 kg per second. The mass flow rate of the fluid B is also 1 kg per second. The specific heat of the fluid, let's denote specific heat by S is 1 kilojoules per kg Kelvin, whereas the specific heat of B is 4 kilojoules per kg Kelvin. Okay, so let's find out first the heat capacity for the fluid A. This heat capacity is the mass flow rate into the specific heat for each of the fluid. So 1 into 1, it is 1 kilojoules per Kelvin. Similarly, the specific heat for the fluid B is your mass of the fluid B into the specific heat of B, so which is 1 into 4, and this is 4 kilojoules per kg. So out of these two, this one seems to be the minimum. So the minimum C min is Ca, which is 1 kilojoules per Kelvin. Okay, so now the heat transfer rate is defined as in the NTU method is defined as the effectiveness into the C mean into the difference of the inlet temperatures of the hot and the cold fluid. So effectiveness is 75%, so 0.075. C mean is 1 into the difference of the fluid temperatures, the 420 minus 20, which is 400. The answer comes to be 300 kilojoules, and therefore the option is A. Okay, so now let's discuss the 55th question. This was for the 54th. Now 55th, they're asking the exit temperature for the fluid B, which is the colder fluid. Let's write colder fluid as A, the hotter fluid as A, sorry, and the colder fluid as B. Okay, so now whatever the heat that is lost by the hotter fluid, that goes to the colder fluid. Okay, so whatever the heat transfer rate is 300 kilojoules, so that is basically the heat lost by A and heat gained by B, and we are asked to find out the exit temperature of B. So heat is 300 kilojoules, and so heat lost by A is not required. So heat is 300. Heat gained by the fluid B is basically the change in the internal energy of the fluid B, which is basically the specific heat into the temperature change. So outlet I'm writing TCO, that is what is need to be found out. So 300 is equal to 4 into TCO is what I need minus TCI is 20. So this comes out to be 75 plus 20, which is 95. So the 95 degrees Celsius. So the option is C. Thank you.